Hey everyone, welcome back. Today, we're diving into how Datadog APM works within a Kubernetes environment, specifically focusing on monitoring a Node.js application. Let's start with a quick overview of the process. First, we have the application pod running inside a Kubernetes node. Within this pod, there's the application container hosting our Node.js application. The key component here is the tracing library Datadog's APM tracer library integrated directly into the application code. Its job to automatically collect traces and metrics as the application processes requests. So, what happens with all this data? The tracing library captures detailed traces, including request paths, execution times, and any errors. All of this is then sent to the Datadog agent pod running in your Kubernetes environment. Specifically, the data is handled by the trace agent container within that pod. The Datadog agent is responsible for gathering these traces and metrics and securely sending them to Datadog's backend. This ensures that your data is transmitted efficiently and without any hitches. Once the data reaches Datadog, it's processed and displayed in the Datadog dashboard. Here, you can see visual representations of how different services within your application interact, latency of requests, error rates, and other crucial performance metrics. Essentially, it gives you a real-time view of your application's health. Now, let's talk about setting this up using Helm. If you haven't installed the Datadog agent yet, the first step is to create a Datadog account. Then, ensure you have an active Kubernetes cluster ready to go. We'll be using Helm charts for installation, which makes the process really straightforward. Just follow Datadog's documentation. Once the agent is installed, verify everything is running smoothly with the kubectl pods command. If everything is set up correctly, you'll see the Datadog agent pod running. You can even describe the pod and check its logs to ensure it's fully operational. Now, let's move on to configuring Datadog APM in your Kubernetes environment, starting with agent configuration. Agent configuration: to enable APM on your Datadog agent, update your Datadog values.yaml file by setting datadog.apm.port enabled to true. Your configuration should look like this: YAML, copy code, Datadog, APM, port enabled, true. After making these changes, upgrade your Datadog Helm chart with the following command: bash, copy code, Helm upgrade f Datadog values.yaml release name Datadog. Application configuration: now, let's configure your application to use the Kubernetes service for APM connectivity. You can either use the Cluster Agent Admission Controller or configure it manually. Cluster Agent Admission Controller: the Cluster Agent's admission controller can automatically inject APM connectivity configurations into your containers. It offers 3 connectivity options: hostip, socket, or service. We'll use the service mode, which adds the dd_agent_host environment variable for the DNS name of the service. Update your Datadog values.yaml with the following: YAML, copy code, cluster agent, admission controller, enabled, true. Config mode, service. Then, upgrade your Datadog Helm chart again: bash, copy code, Helm upgrade f Datadog values.yaml release name Datadog. Injecting libraries locally for Node.js: if you're working with a Node.js application, you'll need to inject the Datadog libraries locally. Here's how to do it. Step 1. Enable the Datadog admission controller to mutate your pods. Add the label admission.datadoghq.com enabled, true to your pod spec. Step 2. Annotate your pods for library injection with YAML. Copy code. admission.datadoghq.com jslib.version, container image tag. Step 3, tag your pods with unified service tags, YAML. Copy code. Metadata, labels, tags.datadoghq.com env. Tags.datadoghq.com service, service. Tags.datadoghq.com version. Step 4, apply the configuration. Once you've added these configurations, apply them, and your pods will be ready for instrumentation. The library will be injected only into new pods, not affecting any running pods. Checking the library injection. After deployment, check if the